In some cases, you need to access values from a previous iteration to do things like computing the relative error. Okay, so let's look at an example over here. So let's start with an initial value of x and then run a loop for I in range 20. So let's run something 20 times, and we want to do the following formula on x, and let's print x. Okay, so the value of x is reduced. I would like to now see the relative error. So relative error is between the newly calculated value and the old value, the previous value, and we would like to find the relative error. So error equal to relative error. So I'm using the function that I created over here. I needed to provide it with the new value, so that's x in my case, and an old value. So I'll just call it x old for now. Okay, if you try to run this, it will give you an error saying x old is not defined. So what you need to do is to store the value of x old from the previous iteration. Okay, so to do so, just go towards the end of your for loop commands and then just type in x old equal to x. So when the first iteration runs, it will store the value of x in this variable called x old, such that the next time the iteration runs, your x will update in line 3, but x old will not update until line 6. So x will update in line 3, and then you can find the relative error between the new value of x and the old value of x. Okay, so if you try to run this, you'll again get the error because the first time it runs, it still doesn't know what is x old. So the first iteration, it just knows what is x, this is the value, a new value of x, and it'll try to find x old in memory, and it won't find it. To fix this, you'll have to initialize the value for x old here. So x old equal to 0. So as you remember from your assignments as well, there is no relative error for the first iteration. Okay, so we'll just post some value for it to do some computation, and this should prevent the error from happening. Okay, so now it works. Let's print the error as well. So you can see the error starts off as 100% and then gradually decreases to 0.004. You can now use the error as a condition to exit the loop, let's say if it drops below 5%. So we'll set up an error tolerance equal to 5%. And then within your loop, at the very end, you can say if error is less than the tolerance value, if it drops below, then break from the loop. Okay. And here you can see as soon as the error drops below 5%, it stops the loop. Okay.